c'est l'extension non, désolé. Notre premier problème. Donc aujourd'hui, on a une présentation avec mon net et il va te montrer aussi donc, une conférence sur les DDoS dans les applications, mais c'est pas juste sur les flux, mais sur les bugs des applications qu'on va faire. On va prendre des questions à la fin seulement avec Star Remote, mais gênez-vous pas, je vais pouvoir les donner. Donc, à la suite de la conférence, à 8h30, on a une réservation pour 3 danseurs. Si vous voulez venir suivre. Ah oui. Si quelqu'un a perdu une sucre, il est ici. All right, so I'll leave you to the conference. Like I just said to them that we will take the question at the end, like we just talked before.
Okay.
So if there's anything, just let me know.
Okay.
All yours.
Perfect. Thank you. All right. So welcome everyone. Thank you for coming to tonight's presentation. Before we get started, I'm going to make the assumption that everyone has an idea of what a DDoS attack is. And so as most of you know that DDoS attacks are on the rise. They're becoming more and more powerful, and they are becoming more frequent as well. And with that, the DDoS mitigation industry is booming. Companies are spending tens of thousands of dollars a month putting all these defenses in place to protect their application. But one thing we notice is that oftentimes companies don't look at what their application can do to actually help protect itself against DDoS attacks. And so tonight I'm going to be talking about some of the common issues we've seen with these third-party defenses, and as well as things you can do with your application to actually help it be protected by these other defenses. So a little bit about me. I'm actually a U of T grad, and I was hired a couple years ago to Security Compass to actually work on training tools. So I was brought on to develop another solution we had for training that gave a sandbox environment. And a few months into my job, I was asked to work on a secret project. So naturally, when somebody asks you to work on a secret project, you don't say no. So I jumped on it, and it turned out what I had to do was find a way to evaluate a company's DDoS defenses. And so I started planning out how to actually do that. And I figured the best solution was actually launching a DDoS attack against them. So I started building our solution, and it's funny because in university, my dream job was developing some software that was super powerful. It would run on a distributed system. It would do some sort of powerful computation, something powerful. A typical comp sci student's dream. And so it turns out that launching DDoS attacks actually fits that bill quite well. And so now I get to actually live out launching DDoS attacks and coordinating thousands of servers to actually, create a DDoS attack and send powerful amounts of traffic at kind of unsuspecting servers. So flash forward to today, I'm now the lead DDoS consultant for DDoS Strike at Security Compass, and DDoS Strike is our in-house service for launching real DDoS attacks against any DDoS defenses or applications put in place, and actually evaluating whether those defenses will withstand a DDoS attack. I built the platform we use for launching DDoS attacks, and I've been building and launching DDoS attacks legally for about 2 years now. So before I continue, tonight's presentation is brought to you in part by the Empire. I'm sure there's a few Star Wars fans out there, so if you're thinking of fighting the rebel scum, consider joining the Empire. So as I mentioned before, DDoS attacks are happening. Akamai reported a 90% increase in DDoS attacks in Q4 of 2015 over the previous quarter. And there's constant news coverage of DDoS attacks. I'm constantly getting emails every day from my Google alerts about new DDoS attacks on companies, extortion campaigns, things like that. And there's a lot of high-profile attacks. PlayStation Network was down recently, and as part of their apology to the user base, they sent out a free day of PS Plus because of it. Xbox was hit before the Christmas break, and even more notable one is the BBC was taken down by a really large DDoS attack. And it's kind of interesting, and really goes to say how powerful DDoS attacks are becoming, because the BBC has been streaming digital media for years now and serving hundreds of thousands, millions of people. And so their infrastructure was actually overwhelmed with DDoS, a DDoS flood, indicating the power that that attack had. So I'm sure there are people in the audience, possibly in the audience, who have been either hit by a DDoS attack or know someone and can probably share a story. Just due to the format of tonight, we won't be sharing those stories. But I can tell you that I do DDoS. I launched DDoS attacks as part of my job. I've launched a variety of different attacks, both volumetric and application. I've launched volumetric attacks up to 25 gigabits per second, UDP junk traffic, and also not as powerful application layer attacks. I've worked with a variety of different infrastructures to evaluate, so things ranging from, infrastructures that don't actually have any defenses and want to see what a DDoS attack will do, to infrastructures that have on-premise and in-cloud defenses that'll protect it from at any routing point. And so it's actually interesting because we typically see a lot of success with the app layer attacks, despite them not being as powerful. And it's really because you don't need as much power to actually be successful. Because of that, they're actually harder to detect. They're lower bandwidth, they can fly under the radar, making it trickier to actually notice it and determine that it's actually a DDoS attack. A lot of times companies are hesitant to block these attacks because they don't know whether it's legitimate traffic, and they're actually scared of being overzealous with what they block and blocking legitimate users. And that's really why companies fear app layer attacks the most, at least from what we've seen with the clients we worked with. A lot of times we hear from companies that we're trying to approach about DDoS testing is that their app is protected. They pay Akamai tens of thousands of dollars a month to have a CDN, a content delivery network, and a web application firewall in place that'll, supposedly protect them against all of these DDoS attacks. And our question always is, have you actually tested it? Have you gone through, tested the different parts of your app, tested the parts that are likely to be targeted? Because there are certain parts of it, even with the CDN defense in place, that will be targeted and could still lead to a potential DDoS situation. And one question we always ask or consider is, have you even looked at your application to see, if the design of it actually helps protect it against DDoS attacks, if it helps make the CDN defense more efficient? So we can't talk about DDoS attacks without talking about the supporting infrastructure. Now, I'm sure a lot of you have seen various different infrastructures, have worked with different ones, probably combinations of load balancers, servers, other on-premise devices, firewalls. So I'm wondering if anybody's infrastructure looks like this. Probably not. I mean, in my past experience, nobody's raised their hand for this. So what if we look at it like this? Still the Death Star. Not your common infrastructure. So maybe if we look at it like this. So we can consider the Death Star a lot like, an actually common infrastructure, where at the very core of it you have your origin server serving your applications. Along the way you have routers, firewalls, on-premise devices, maybe even load balancers. And at the very outer layer defense is where you have your content delivery network that's serving static content and absorbing most of an attack, if there is one on your infrastructure, for the most part. So a more simplistic view is this, and this is actually a generalization of a lot of the infrastructures we actually work with. And so some combination of these components we'll see and it's something we commonly test. So even with all of this, there are still issues. You're not fully protected. And it's surprising actually that we see some common issues amongst people with similar infrastructures. So even with CDN layer defense, we still find issues similar to any sort of pen testing where people have done their due diligence. You can still most of the time find some sort of security issue. And when you're thinking about CDN defenses, you can think of any issue as a vent hole in the Death Star. So some way to bypass the CDN defense and completely bypass the defenses and actually attack the origin infrastructure itself. For CDN defense, one vent hole is actually getting access to the origin IP. If you can get access to the origin IP, you can potentially bypass a CDN defense just because of how they're typically set up. What we've typically seen is they'll use DNS to route traffic to the CDN defense, which will proxy any requests or serve requests from the network and proxy any requests it can't serve back to the origin infrastructure. So the vent hole there is if you can send traffic directly to the origin infrastructure, your defense doesn't do anything for you. And so one vent hole is potentially when your application leaks the IP. So if your application leaks the IP, an attacker can then bypass your defenses. With the CDN defense, you want to make sure that you want to consider your origin IP sensitive data. So this can actually be considered one of the OWASP top 10, the A6 sensitive data exposure, if you're leaking your origin IP to an attacker. And there could be a number of different ways. It could be in the response bodies, even in the headers, or even worse, if it's logged in some file somewhere that's somehow publicly accessible, either through other vulnerabilities or just a really bad security setup. And like I said, all of this can allow traffic to be directed to the origin server. Another kind of avenue or play on that is when response bodies or HTTP headers leak some sort of fingerprint. So we've seen F5 devices where they'll send back the HTTP header big IP, which is an F5 proprietary technology for fighting off DDoS defenses. So right away from there, we know we're working with an F5 device, and if we can get access, we can find out through other means the block of IPs that company owns, and then just start enumerating it to see which servers or which IPs return a similar header, and kind of match up the IP that way to the fingerprint we found through through some sort of leak. And in that case, through that means we have the origin IP, and again, can attack directly to the infrastructure. Another common thing we see, a common way we see origin IPs leaked is through DNS. So one actually very common scenario is where the root domain, let's say example.com, will actually point to the origin IP. And when users go there, or when the browser goes there, it'll send an HTTP redirect back to actually go to www.example.com. And from there, that'll point to the actual CDN infrastructure. And obviously this is an issue because again, it's an easy way to discover the origin IP. And even though can only send a small amount of traffic to that origin IP, you can still send traffic to it. And when we're talking about DDoS, we can send massive amounts of traffic to it, even enough to just knock it off. And in some cases, we've been able to do that. There have been specific cases or specific services running that we send it enough traffic that it has memory issues or something, and suddenly it'll stop accepting connections. TCP connection floods is another thing you can do, and then anyone trying to navigate to example.com doesn't get that redirect anymore, is unable to connect, and you're successful with your DDoS attack. There's a number of different DNS records that can also expose the origin IP. We've seen old and outdated records, subdomains, so it might not be example.com, but it could be blogs.example.com, but it'll still point to your origin infrastructure. and any other type of records like mail records or authoritative DNS records. So the way to help protect yourself from those kinds of leaks and really just protecting your origin IP is to subscribe to BGP-based services. With that, your service provider is now announcing your IP space. So either Akamai or one of the top DDoS mitigation providers will actually announce your IP space and route traffic through their infrastructure first, so that even if you get the origin IP, they can still scrub the traffic before it gets to your infrastructure and keep you protected. There are a number of different services also that are supposed to protect your origin IP. Akamai has one called Site Shield, and typically BGP is the way to go. One major defense of CDN providers and web application firewall providers is rate limits. And rate limits are intended to determine potentially non-human clients. So those are, if a malicious bot is trying to attack a site, they might be requesting it at a non-human rate of 10 requests per second. Typically, the applications or websites I've seen, there's no need for a person to, request the same page over and over again, so repeatedly. And so rate limits are intended to detect that and block out those malicious IPs, or potentially malicious IPs. Because there might be a rare case for some sites, let's say a ticket site. If you're trying to get tickets for an event, you might sit there hitting refresh over and over again just to try and get the tickets you want. So in some cases, a legitimate client could actually, make a request too many times, request the page too many times, and get themselves blocked. So they implement, third-party defenses implement a short block period time. Sometimes it's adjustable, and so it'll really depend on your provider. We've seen times between 2 minutes and 5 minutes. And there's a number of different rate limits that you can actually use to help protect yourself. There's monitoring rates of requests per second, concurrent connections per second from a single source, and even the link speed. Typically, depending on your client base, most of your users will have a decent speed, internet connection speed. And so the really slow ones could be a sign of malicious users trying to do something like a slow lowers type of attack. So even with the rate limits, we've still found issues when we're testing clients. And rate limits are commonly the most misconfigured defense that we've seen. A lot of times we'll go into a test. The client will be confident that it's protected because it has these rate limits and it just wants us to verify them. However, we go in and we don't actually see a rate limit take effect. And that could be either a misconfiguration, they're not switched on for whatever reason, or even that they're configured to be too high for the application. That's another scenario we see a lot of, where they arbitrarily set a rate limit on an application, but even the amount they set is too high, and we can easily fly under that radar, distribute our load to thousands, couple thousand of servers, and still be able to take that server down. And we'll still be doing 9 requests per second if they have a rate limit of 10 requests per second, which could still be considered non-human, depending on your application. One other thing we see is that rate limits are only configured at the outermost defense. So they'll be only configured on the CDN, third-party CDN or WAF provider. And that's kind of an issue because we had talked about a vent hole being the origin IP. So if I can bypass the CDN, I can bypass those rate limits, and then suddenly there's absolutely no defenses, and you can't even block the most simplest of DDoS attacks. So you want to be able to rely or improve your rate limits to help protect your infrastructure. And to do that, you need to know what limits you can put in place. So I mentioned before there are three examples. Those are requests per second, concurrent connections per single source, and link speed. And to really know what to set those values, you need to establish a baseline. So baseline will involve monitoring the traffic to your site for a period of time. We typically see 2 weeks, or suggest 2 weeks at least. And so you can calculate averages and standard deviations and figure out which pages are accessed most frequently and things like that. And that'll allow you to set same rate limits for the different pages in your application, for the different parts of your site. If possible, you want to set exponentially increasing block times for repeat offenders. So anyone that's constantly, they'll violate or they'll go past one of the limits, they'll get blocked for a period of time. If they come back and go above that rate limit again, that's even more indicative that they might be some sort of bot. And so you want to block them for a longer period of time, because there's actually a case where an attacker will roll through a different set of IPs throughout the duration of an attack. So it's one scenario we've actually executed ourselves, where we'll have pools of attacking nodes, and basically when we detect that one pool is blocked, we'll just rotate to the next pool. And even though the first ones are blocked, we've got a fresh attack going, fresh IPs, and those ones aren't blocked, and they continue to take down the site. And we'll just keep rotating it depending on what the duration time, if it's static. And in that scenario, we might not be able to keep a consistent downtime, but we can keep knocking the page offline, online, offline, to the point where any users of the site will probably be ticked off and will complain, might send an email to support, might call your support center if you have one, and will typically not want to use your site. They'll lose confidence in it. Another way to improve your rate limits and make sure they're more effective is to not use a global rate limit. And that's something we've also seen as well. Basically, clients they'll do some sort of baselining, they'll go through that activity, but they'll only set a limit for the entire site. And that's kind of an issue because different parts of the site are used at different rates, basically. You might have, again, we'll go back to the ticket site, where there's one page where users will refresh a bunch of times to get the tickets, but when they're logging in, they'll typically only interact with that page maybe once or twice per session. And so there you can set an even stricter, on the login page, you can set a stricter rate, just because typical use will be very low. And that'll allow you to better protect the login page, which is actually one of the more common targeted attacks when you do have CDN defenses in place, because it needs to be processed by the origin server. And so more stringent controls can be placed on it to help protect that part. I mentioned before that another issue is only setting rate limits at the outer perimeter on a CDN or WAF service provider. And you really want to enforce limits at all the different layers because of the issue of bypassing some of those defenses. So you can do this on on-premise devices, routers, firewalls, even in your application server like Nginx. Nginx, you can set rate limits, bursting limits as well. And so if you can configure it at multiple different layers, you have a better chance of protecting yourself and blocking out even the most simplest DDoS attacks. Finally, you want to verify that it all works. I mean, if you go through the motions, set everything up, spend the time to put it all in place, you want to test it. You want to test that it works as you expect it to, and that there aren't any holes, or that the limits you put in place are actually able to protect your application from a DDoS attack. So even with all those defenses, we still see other issues. Some sites will allow slow connections, and I mentioned before that'll open you up to slow lowers type of attacks. We've seen servers that aren't tuned properly and haven't adjusted the open file limits or TCP connection pool limits to a same amount, and so it's actually really easy to exhaust all of the TCP connections on those servers. We've seen a rare case actually where the CDN provider would allow invalid HTTP requests. We were trying to do a slow lowers or slow post type of attack, where we'd send a post request, but we'd never end the request on our end. Instead, the CDN provider would close the connection, and what we saw was happening was that it would actually forward that request back to the origin server anyways, despite it being invalid or despite us never completing it. And the origin server would process it, and we were able to effectively bypass the CDN through that post attack. We've also seen servers with memory issues, and this can be more on the application side, where your application either has a memory leak or certain operations are memory hogs. And if we hit it numerous amounts of times, not even necessarily huge amounts of times, we can still cause it to use up way too much memory and have the OS actually start the process, taking it down for a few seconds. And we just sort of repeat that to keep taking it down over and over again to really destroy the usability of the application. So even with all these defenses in place, let's say you verified they all work, your rate limits are good, they're adequate, what can you do to actually help bolster your defenses, improve your defenses? And you can look into building a better Death Star, building a better application, either it's more efficient or just certain designs will help your defenses protected. So with the CDN in place, your major issue now is dynamic requests. They give you issues, you can't control them, simply because they need to be sent to your origin server. Your origin server needs to process it. And these are pages like login pages, where a user will send credentials that a database needs to be interacted with to verify them. Search pages for any sort of stored content on your server or in another database. Authenticated pages, typically you don't want to cache those. There's actually a recent issue with Steam, where when they were under a DDoS attack, they made some tweaks to their CDN pages, or CDN configuration, which caused authenticated pages to be cached and served to other users. And so that was a huge issue for them, because it was actually leaking other user details, just because those pages were cached. And any form submission will also need to be processed by your origin server. And these kinds of pages are the main target for DDoS attacks. It's what we look for when we're doing an engagement. Anything that will allow us to send traffic or cause some sort of processing on the origin server. So what can you do to help reduce the impact of these dynamic requests, or reduce the impact of a DDoS attack? You can try to make things more static. You want to make things as static as possible on your application. Specifically, I'm talking about websites here. So you want to abstract as much of the site structure into some sort of cacheable format and make it easily cacheable by your CDN provider. So that'll be things like your JavaScript, your CSS, any HTML. These are all typically static and can be cached, and anytime a user requests it, it'll be served by your CDN rather than your infrastructure. Even if you're using a front-end template engine to render dynamic pages, that can easily be cached too, and again reduce the load that your origin has to process. Another thing you want to do is consider how dynamic your data actually is. If you're aggregating news results from various different sources or something like that, you might not actually update that. Let's say you only update it every 30 minutes. Something like that can still be cached for that 30 minutes where it's never updated. And you can actually configure your CDN to invalidate that page after whatever time that it's valid for. And the next request for that page will cause the CDN to make a single request to your infrastructure and update its own cache. In that case, if a DDoS attack is attacking you, it'll only result in 1,000 nodes sending requests to that one supposedly dynamic part will only actually result in a single request every 30 minutes to your origin infrastructure. So again, the CDN is taking the impact of the load of the DDoS attack and keeping your site and application up and running. Another thing you want to do is limit interactions. So pages where either those form submissions or login pages, you want to be able to limit how many times a user can submit to it through the actual application. And this is for the case where if you have a login page the actual process of connecting to the database and verifying those credentials can be resource intensive. So if I'm an attacker and I'm still sending 3 requests per second, let's say, it could still be enough of a load from 1,000 different servers or attacking agents to knock your application offline, or even knock your database or choke up your database. And that kind of behavior is still, not typical and might be blocked by your CDN defense, but again, you want to have multiple layers just in case it's somehow bypassed, or whatever rate limit you've put in place isn't, if I can fly under it, you still have some sort of protection. And so what you want to do with these limiting interactions is probably using all the methods you already use, and things like sessions or cookies to help block out more simple botnet attacks. Botnets that can't store cookies and send them on subsequent requests will not be able to interact with that specific page if you validate the cookies first before any sort of other processing happens. The next step up is using CSRF tokens, which you should already be doing, especially for form submission pages. These block out any sort of botnet attacks that cannot do any sort of HTML parsing, because it can't parse out that token out of the page. The next step up, and this will block majority of DDoS attacks out there, except the most advanced ones, is using JavaScript cookies. And this is actually what a lot of DDoS defense providers use themselves as a sort of challenge. They'll inject a snippet of JavaScript into your page, which will run on the client's computer, set some sort of cookie or some sort of value, and return it on the next request. And that validates that the client's running a legitimate browser, or at least something that can process JavaScript. Other tools you can use are any sort of anti-automation controls. So another example is actually CAPTCHA. And some DDoS defense providers use that too, but kind of as a last step because they're not as user-friendly. Even Google uses this to some degree when you've made too many search requests on their page. They'll present you with a CAPTCHA just to verify that you're not actually a bot, so you're not abusing their infrastructure. Another thing to consider is how scalable is your application. You might not need to scale, depending on your user base and things like that, but you still want to design your application so that if you are receiving a very high load for traffic, you can scale out to kind of absorb that impact. And this will help you in cases where there's some sort of hole in your other defenses, or even just some of the delay that exists between when you get attacked and when your defenses are actually able to fully scrub out that attack. And with some of our engagements, we've actually seen times of up to 45 minutes where we started an attack, took down a site, and it took the DDoS defense provider 45 minutes to write a custom rule that'll filter out the traffic and then slowly roll that out to all of their edge nodes. So in that time, you have downtime. And while they're mitigating, it's a slow rollout. And so you're still taking, depending on the size of the DDoS attack, a huge hit from it. From that AWS actually released a white paper recently for when you're running applications on their infrastructure, where their recommended defense against DDoS attacks is to actually use their Elastic Beanstalk service. And the Elastic Beanstalk service will dynamically scale out your application by spinning up additional VMs that'll actually be load balanced and join the load balancer and do some of the processing and spread out that load. This is kind of an odd defense coming from AWS, because right away it implies that their DDoS defense is to just pay for more of their infrastructure and they make more money, obviously. But really just ensuring you have some sort of dynamic scaling will make it more cost effective, so that only when you're under a DDoS attack, you're actually being attacked. And you don't just have tons of infrastructure lying around that most of the time is doing nothing. There's even the concept of hybrid scaling, where you have physical machines in your data center, and when loads get too high, either through DNS or other methods, we'll actually start splitting that load between auto-scaling infrastructure in the cloud and your own on-site infrastructure. And in that case, you can still see some cost saving from running your own infrastructure, and again, only scale out to the cloud when you need it. So DDoS attacks are not just a network problem. If your application can be easily taken down, it becomes everyone's problem. You want to make sure that you're actually testing the defenses you put in place, because any sort of small issue, configuration issue, or any overlooked part of your defense could result in a DDoS attack, and that could actually cost you tons of money, depending on what your application does. Potentially lose revenue. Even retail stores, any online store, if they're down, they're losing revenue. And so you want to make sure that all of your defenses are tested, and not just tested a single time when you put them in place. You want to continuously test. Test as you make changes, test if anything in your infrastructure changes, or even just over time to make sure that your people and your processes that are handling these DDoS attacks are trained. They can recognize a DDoS attack. It's actually something we've seen before, where we've launched a DDoS attack, but the people responsible for monitoring and defending the infrastructure, they didn't recognize it. They just thought it was some sort of application issue. And it took them actually a week and a half to realize that it was probably a DDoS attack. And like obviously a week and a half later, it's too late for them to start putting defenses in place. So you want to continuously test and verify so that, again, your staff is trained, they can recognize it, and that your processes make sense and are actually able to help you recover from those kinds of attacks. So I'd like to thank you all for listening to me. Hopefully you've been able to take something away from it to help protect yourself against DDoS attacks, because if you haven't experienced a DDoS attack, I might be coming for you. Thank you.
Thanks, Michael. I'll just ask for the question.
Yep. Are there any questions?
Je vais la poser sur le site. Ou je l'ai peut-être. Just a sec, he's coming.
Okay.
All right. Okay. Just a small question for you. During Christmas on Amazon.com, so you have a lot of connections at the same time, and if you have someone who is using a botnet, you will have a lot of concurrent connections at the same time. So the rate limits are not working at that moment because your application is highly used. It's 2 weeks before Christmas. So how can you detect if it's a DDoS attack?
So it'll really depend on your application. Some of the more advanced DDoS defenses will detect some sort of behavioral pattern for how the site's actually used. So that'll involve, if you have a multi-page application where the logical order of a page could be, going to the home page, going to the login page, going to another page. Any sort of malicious user that is just hitting a single page over and over will be identified as suspicious or something. And in that case, you can detect them in that way. Again, if you notice, with specifically Amazon, you can get notifications about when your infrastructure is scaling out because of these concurrent connections or usages. And from there, your staff will have to, any staff involved in your SOC or that are responsible for mitigating the attack could potentially take a closer look and, hopefully they can recognize that there might be some sort of, hint that it's a DDoS attack. It really depends how sophisticated the DDoS attack is as well. Only the most sophisticated attacks will, bypass all of those controls. So a lot of the time, 90% of the attacks you'll see will be basic or simple in nature, where they'll just request the same page over and over again. and in that case, you might be able to detect it despite what the rate limits are.
Thank you. Any other question? All good? Well, thanks again, Michael, and it was a great presentation. So I'll talk to you soon. Thanks, guys.
Thanks for having me, guys.